Now we're recording for our mission trip people who are wide awake, I'm sure, on an airplane about now. Regular polygons. When we have, what's a regular polygon?
They're angles.
Angles and sides all congruent. A regular polygon, all angles, all sides are congruent. When we have a regular polygon, we can have a center to that polygon and a radius of a polygon. Usually we think of a radius with what shape? A circle. Now you notice they have inscribed this pentagon inside a circle. And if a polygon is inscribed in a circle, the circle hits the vertices, and so the radius of the circle goes from the center of the circle and the polygon to a vertex. So it is the radius of the circle, but it also is called the radius of a regular polygon. It has to be a regular polygon before we can have a radius to it. Yeah?
Does it have to be inscribed?
No, we can remove the circle and it's still called the radius of that regular polygon. To the vertex or to a vertice, to a vertex or two vertices. You're correct. So I could go from point P to point C or point P to point D. Any of those would be a radius. What's that? No, it can't. Now we are going to talk about that line, but that's not a radius. A central angle of a regular polygon. We know what a central angle is for a circle. It's an angle that is centered or has a vertex on the center of the circle. Well, if I draw two radii or two segments in the polygon from the center to a vertex, then I get what is called the central angle for that polygon as well. And we are going to be using these values to help us figure out a formula for the area of regular polygons. Now, this line that you see drawn from the center hitting the middle of the side, so this F would be the midpoint, and it's perpendicular to the side, has a special name, apothem, right there. It's called an apothem. Sounds very sophisticated, doesn't it? Like you are educated when you say it.
We have a apothem that comes.
Do you have a apothem that comes? Does it play dead? And other bad jokes? All right, an apothem goes from the center to the midpoint of a side, and so it is going to be perpendicular right there. So now that we have all of those values, could we figure out what the measure of a central angle is in a regular polygon? Well, if you went all the way around the center, how many degrees have you gone? 360. So if I take 360 and divide it by, how many pieces on this polygon would I divide that 360 by to figure out that one? 5. Because if I made central angles going to these vertices, 1, 2, 3, 4, 5, I have 5, one for each side. So we could divide it by 5. What's 360 divided by 5? A number, I agree. We're a little more specific in math usually. 72. So that central angle is 72 degrees. Could you tell me the measure of this angle in the right triangle that's formed by that apothem right there? 36. Because this apothem is going to cut it in half. Now that 36 degrees does not make a special right triangle. It's not a 30, 60, 90. But it does make a right triangle with an angle, so I bet we could use trig functions if we needed to. Sine, cosine, tangent to find some missing lengths. Oh, yeah. All right. So let's come down here. In the figure, regular hexagon. Hexagon is what? Six-sided. JKLMNP. So JKLMNP, we just start around. Inscribed in circle R. Identify the center. Well, let's do that. Where's the center? R. So this isn't very hard. Point R, just a capital letter. The radius, what's the radius? Okay, the one that they have drawn, RL or RK, RL, RK, either of those would work. And there are more, of course, but the ones they have drawn, they are there. The apothem, what's the apothem? RS, apothem, RS, and a central angle. Central angle. Angle. KRL. Could have said LRK if we wanted to as well. Either way.
Or could we have just said angle R?
No. Angle SRL, SRK, etc. Then find the measure of that central angle. So tell me how we are going to get the measure of that central angle. 360, we'd have to divide it into 6 parts because that's how many sides we have, and that gives us 60 degrees. So if I looked at this little right triangle formed by that apothem, what type of triangle? That's a 30, 60, 90 triangle. It is a special triangle. The cover of the hot tub shown is a regular pentagon. If the side length is 2.5 feet, so there's the side, 2.5 feet. Kind of a small hot tub, isn't it? Yeah. Anyway, and the apothem is 1.7 feet, so there's our apothem. Find the area of that lid. Well, what's that? Meters would certainly make it bigger, wouldn't it? So I don't know who dreamed up 2.5 feet, but maybe it's for little kids. I don't know. I bet we could work on figuring out the area of this triangle they have drawn there, because we know the area of a triangle. What's the area of a triangle formula? 1/2 base times height. So 1/2 of, do I know the base of that triangle? 2.5. Do I know the height of that triangle? 1.7. So tell me that part. Now that's just the area of the triangle. 2.125? 2.125. What would I do with that then to get the area of the whole cover? Multiply it by 5. We'd have exactly 5 of those triangles. 1 there, 2, 3, 4, 5. So multiply it by 5. How much do you get? 10.625 feet square. Round to the nearest tenth, they did say. So we would 10.6 feet square. I know, I got caught on my tail, didn't I? All right, let's see if we can't use kind of this idea right up here and figure out a formula for the area of regular polygons. So we are going to look at this right over here. If I made, what line is this that I just drew? The apothem. If I made that apothem, and then this green triangle right up there, and if I called that apothem length A, and I'm going to call the length of the side of this pentagon S, what would be the area formula for that little green triangle? 1/2 of the base, which is what? S, times the height, which would be A, correct? Now, if I multiplied that triangle area by what? 5, it would give me the area of the whole thing, wouldn't it? Now, instead of just saying 5, I'm going to say N equals the number of sides. So I am going to multiply this by N for number of sides. Now I'm going to rearrange this a little bit here. Now we have the area of the polygon. Now it's turned into the area of the polygon when we multiply it by the number of sides. I am going to put S times N together. What do we call the length if I take the length of a side times how many sides? What do we call that? Well, not circumference. The what? Perimeter. S times the number of sides, S times N would be the perimeter. So I'm just going to call S times N P. Bring down my 1/2, bring down my A, and I have just created a formula that works for all regular polygons. Ta-da! I don't know if you're keeping notes of area formulas for this chapter, but this would definitely be one that, well, probably is new to you. 1/2 apothem times perimeter. Any regular polygon. Notice I didn't use any numbers up here. It was a pentagon, but I didn't need to use 5 or something like that. I just said n, number of sides. So it could work for a decagon, a dodecagon, a square, a whatever regular polygon. Now remember, this has to be a regular polygon, regular area of a regular polygon. Otherwise, we don't have these radii and apophthegms and things like that. So let's try this new formula and see if we can get areas of shapes down here. I know that this is a triangle on this part A, and that we have another formula for the area of a triangle, but we're going to work with area is 1/2 apothem times perimeter. Perimeter times apothem. Which way does your book do it? Apothem times perimeter. I wrote perimeter times apothem. Oh well, it works either way. 1/2 apothem times perimeter. So let me draw the apothem. That would be the apothem right there. And then I am going to draw this radius right over here. I'm going to change colors to, oh, I'm not even going to draw that one in. I don't think we need to draw that one in. Can you tell me the measure of this angle right there? How much? 30. How do you know it's 30 degrees? Well, a regular triangle has 60, 60, 60. And so we just cut it in half with this radius right over here. The radius will do that to all these regular polygons. It will cut that angle of the vertex in half. So I do have, I heard it back there, a 30, 60, 90 triangle. What is the length of this side of that triangle? Look at the figure. 2. The whole side is 4 feet, but the apothem goes right to the middle. So that's 2. Is that the long, short, or hypotenuse of that 30, 60, 90? The long leg. So I'm going to go back to the short leg, which is also the apothem. Well, you're close. If I knew the short leg, I would multiply by the square root of 3 to get the long leg. So if I know the long leg, we are going to do what? Divide by square roots of 3 to come back to the short leg. Now, all I need to know is the apothem and perimeter. I have enough information. 1/2 the apothem. What's my apothem? 2, not 2 square roots of 3, 2 divided by the square root of 3. And correct, we wouldn't leave it this way. We wouldn't leave it with the square root of 3 on the bottom. Times perimeter. What's the perimeter of this thing? 12. Where do you get 12 from? 4 times 3. There are 3 sides. So let's go ahead and go to a calculator, but I'm going to do a little bit of reducing. That 2 reduces that 2, so I really have 12 divided by the square root of 3.
Divided or multiplied?
Divided. That square root of 3 is on the bottom denominator. That 12 is on the top. Now I'm going to write this in the exact answer, which means I would rationalize it, but I also want you to get me a decimal for this one. 6.92, so about 6.9. So if I was rationalizing it for an exact value, 12 square roots of 3 over 3, and what's 12 divided by 3? 4 square roots of 3. Try 4 times the square root of 3. Do you also get approximately 6.9? Better be exactly the same answer. All right, so there's our new formula. Worked beautifully. Even works in this square. Now all of these are regular polygons. Area equals 1/2 apothem times perimeter. So let me draw that apothem, which is a 90 degrees. Can you tell me that angle right there? What is it? 45. So this is a 45, 45, 90 triangle. I know the hypotenuse. How could I go back to this leg? Divide by the square root of 2. 7 divided by the square roots of 2. So the area must be 1/2 the apothem, 7 divided by square roots of 2, times my perimeter. Oh, we're going to have to think about that. What length is that side? 7 divided by square roots of 2. So how could I get the perimeter? If I doubled that, 14 over square roots of 2, that would be 14 over square roots of 2. What would you need to do with that number to get the whole perimeter? Times 4. What's 4 times 14? 56 divided by square roots of 2. So right over here, 56 divided by square roots of 2. Now, I'm not going to my calculator yet because it's actually easier doing it this way. What's square root of 2 times square root of 2? 2 times that 2 on the bottom, which makes a what in the denominator? 4. 1 times 7 times 50. I don't know. What's 7 times 56? 392. Does that divide evenly by 4? 98. 98 centimeters squared. There is our answer. So we can work with the exact values, and in this case, it even came out to be an integer. So let's try this one. Okay, again, we know area is 1/2 apothem times perimeter. So I need to figure out where my apothem is. Right here to make a nice... Whoa, that is an apothem, isn't it? That's what you started to tell me. That is an apothem. That is my apothem. Now I want to make triangles, so I'm going to draw it right there. Now I want to know, what's the measure of that little angle in the triangle? How can we figure it out? Think a minute. See if you can get that figured out.
Maybe 8 out there. Something with 8.
360 divided by 8?
Maybe I should start with another angle. If I took 360 and divided it by 8, I would have this angle up here, right? Why don't you do that? 360 divided by 8. 360 divided by 8 gives us what? 45? And then if I divide that by 2, I get 22.5 degrees for the angle right in here. So let's not worry about the angle down here. Let's worry about this 22.5 degrees up there. Their picture's too tiny. When you're drawing pictures, you want to draw bigger pictures. All right, so 1/2 apothem. Do I know the apothem? 8, they gave it to me. I need to find the perimeter. Well, I can work on this side of that triangle. I'm going to use sine. Sine of 22.5. Sine of 22.5 equals, sine is what over what? Opposite over hypotenuse. Opposite of that 22.5, let me call it x. Do I know my...
No, you won't.
I don't want to use sine. Opposite over hypotenuse doesn't do me any good.
Oh, no, it's tangent.
Let's use tangent. Tangent is what?
Opposite over 8.
Opposite over adjacent. X over, what's the adjacent? 8. So if I want to get x by itself, I'll multiply by 8 to get rid of this divided by 8. Well, you tell me. What's 8 times the tangent of 22.5? 3.3? Why don't you give me another decimal place? 3.31? All right. Now in my formula, I'm just missing the perimeter. What could I do with that 3.31? And actually, I'd leave the whole number in your calculator. What could I do with that to get the whole perimeter? Times 16. Why 16?
That's only half.
Yeah, there are 8 sides, but that's only half the side. So we have to double it, then times the 8, or times 16. 53.01? 53 point, if it's 019, then it'd be 02. 53.02. So half 8 is 4, 4 times that. What is our area? And round to the nearest tenth for me. 212.1? 212.1 inches square. So we have seen one where we needed to do the trig ratios. We've seen a couple where we use special triangles. You're going to run across that stuff, but you can handle it. Composite figures. Composite figures simply means they are composed of more than one figure. We're putting different shapes together. So I just need to figure out the area of the pieces and add them together, and I can get the area of the whole thing. Now we can divide up these shapes different ways. If you look at 4A, how may you want to divide it? Any ideas? A triangle? You could pull a triangle out of
That
it.
could be 3 triangles.
What I am going to do is simply this. What shape is this over here? That's a trapezoid. Now you could divide it up and get a little triangle and other little rectangles, but just dividing this line, that could give me a trapezoid. Let's call this area 1 and this area 2. Area 1 is what shape? A rectangle. So I'm just going to go 8 times 12. Area 2 is a trapezoid. What's the formula for the area of a trapezoid? 1/2. 1/2. I like your base 1 plus base 2, but I need half of something first. Half the height. 1/2 the height. What would I call the height of this trapezoid?
No, 7.
Where do you get 7 from?
15 minus 8.
Yeah. This whole thing was 15 across the bottom. Up here was 8, so if I drew that line down, I've cut off 8 from the 15, there's 7 left over. 7 must be the height. What would I call base 1? 5 could be one base plus 12 the other base. Perfect. And then I just need to add those two values together. I'm going to let you do it. Do it on your calculator. You can do it all at once. You can take 8 times 12 plus 1/2 times 7 times, I'd call that 17. 59.5? Nearest tenth, they say. 59.5? 59.5 inches square. Beautiful. Let's try this one. Is that not the area of the whole thing?
No, that's the area of the trapezoid.
Oh, we need to add the 8 times 12. We want the area of the whole thing. So we've added it both together. 155.5? 0.5 inches squared. Okay, for B, what shapes might I use?
Triangle, rectangle.
Well, I've got a circle. At least I have a half a circle, right?
This is just the formula.
And then what's the rest of it? Trapezoid. Trapezoid. You can chop it up into smaller pieces. I'm just going to do that trapezoid stuff. I'm going to call this 1 and 2. So the area of 1 is going to be my trapezoid. 1/2 the height. Do I know the height of that trapezoid? We don't know the height of that yet, do we? So we're going to have to figure out the height. So let's draw this nice little line right there. Can you tell me how long that side is?
Oh, what's 31 minus 22?
Okay, what's 31 minus 22? 9. Now, can I figure out how tall this thing is?
That's also 9.
It is? How is it also 9?
Well, no, we don't know if it's we don't know.
Yeah, don't guess that it's some special triangle. Pythagorean theorem would work. Is it a special triangle? Or I shouldn't say special, but a Pythagorean triple.
Yes. 3, 4, 5.
It's a 3, 4, 5. 3 times 3 is 9.
So it's
5 times 3 is 15. So 4 times 3 would be 12. Or Pythagorean theorem. That will find you that value. So back here to area 1. 1/2 the height. Do I know the height of it now? 12. Times base 1. What's base 1? 22, 31. Doesn't matter to me which one you call it. And then area 2 is, well, we have half of a circle. So let's do half of, what's the area of a circle? Pi times radius squared. Do I know the radius of that circle?
6.
6. The whole thing is 12. So the radius would be 6. So why don't you go ahead and get those values, add them together, and tell me the final answer. Radius would be 6 because the whole height between those two is 12.
200.
So on the left side, so on the right side. Is that the final answer or just part of it?
I added it together.
That's what I want. We got two answers. We'll see if we get agreement. What do you get, Jet?
219.5.
219.5. What'd you get, Lonnie? 374.5. We need some more participants. Another 374.5.
374.5.
Yeah.
374.5 centimeters squared. Centimeters squared. Now I'm going to talk about these down here. We actually won't do the math on these because we need to move on. But I want to find the area of the shaded region. So if I find the area of this whole shape, I could then do what? And subtract that triangle. And right down here, this little triangle doesn't touch the bottom. There's still 1 meter gap right in there. So I'd find the area of the whole thing, which is a what shape?
Trapezoid.
A trapezoid. It's a trapezoid. Now I don't know the height, but could I get the height? How could I get the height?
That's Pythagorean Theorem.
I'd use the Pythagorean Theorem. This would be a 1, that tiny little thing there. That's a 1, that's a 6. I could get the height of that triangle from the Pythagorean Theorem. I then would add 1 to that to get the total height of that trapezoid that I have. Okay? So you could handle that. Over here, I'm supposed to get the area of that shaded region. We wouldn't get these 4 little pieces. We'd get the area of the whole thing, which is a what?
Parallelogram.
Parallelogram. Maybe I should do this one. Area of the parallelogram. What's the formula for the area of a parallelogram? Base times height. What's the base of that parallelogram? 14. What's the height? 9. Oh, beautiful. 9, the height.
Yeah.
Now I need to figure out the area of that. What shape is inside? Kite. What's the formula for the area of the kite?
Is it diagonal or diameter?
Diagonal.
Diagonal 1, diagonal 2.
Diagonal 1 times diagonal 2. What's diagonal 1 if I call diagonal 1 that one right there? 14. Diagonal 2. Yeah, the other one is 9 right over here. Beautiful. So this time I need to take 14 times 9 minus the kite from it. Tell me that final answer. Let's see if we can get some agreement there. It's 14 times 9 minus 7 times 9. It's really just 7 times 9, 63. 63 feet squared. Okay.
You're trying to find the shaded area, but the kite is there.
Right.
Whole area parallelogram, but subtract the area.
Exactly right. That's the answer. The kite happened to be exactly half of the parallelogram. The kite's 63, and so when you subtract 63 from that 126, you get 63 all over again. All right, let's go to the book. Let's see, what page are we on here? 811. Geometry, 811, number 1. In each figure, a regular polygon is inscribed in a circle. Identify the center, radius, an apothem, and a central angle. Then they want us to find the measure of a central angle. Oh, I'm reading the wrong thing.
That's right.
Nope. Go to the top. You did the same thing I did. That was number 8.
That was number 1.
In the figure, oh, well, it sounds the same. I was reading above number 8. In the figure, ABDC is inscribed in circle F, but they're saying the same things, aren't they? Identify the center, radius, apothem, and central angle of the polygon. Then find the measure of a central angle. All right, so what's our center? Center is F. Center, F. Radius, CF or DF. I'm going to call it FC or FD, just because I'm starting from the center. Those are segments. They do, but I want to make sure that I cover all my bases. Center, radius, what do they want? Central angle now? Oh, apothem. They wanted an apothem next. which, by the way, is not the same word as opossum, even though it sounds a little bit like that animal. All right, apothum. FG is the apothum, and that's the segment. Now, central angle. Name of it. CFD, angle CFD, or reversing those orders. And then they want the measure of it. So how would I get it? How would we get it? Not the answer. 360 divided by 4. So if I take 360 divided by 4, we get how much? 90. Central angle is 90 degrees. 2. I have 4 sides to that polygon. And remember, the central angle is the complete angle that goes to, let's come back over here. Central angle is this complete angle right there. So if I want the measure of a central angle, I take 360 degrees divided by 1, 2, 3, 4, 5. Number of sides. That gives me my central angle. Number 2, find the area of each regular polygon. We need to have sketches of these shapes. Because we need to be drawing in these shapes. All these things that we need to figure out. Is that a 6-meter side? I write my formula, and then I just find the numbers that go in my formula. 1/2 apothum times perimeter. Now I could fill in the perimeter already. 1/2, I'll leave a space for my apothum. What's the perimeter? 18. Because it's a triangle, 6 times 3, 18. Now I just need to get my apothum. So we will pick a center and draw down, make ourselves a nice apothum. And then you want to draw a triangle out of it and figure out some angle. I think I can figure out that angle. Well, that would be a 30-degree angle because we started out with a 60-degree angle there. So it's a 30, 60, 90. I know this side is 3, which happens to be which leg? The long leg. So I need to divide it by the square root of 3, and I just figured out the short leg, which is the apothum. So 3 divided by the square roots of 3. I can fill into the apothum. Now I'm going to do first the exact answer, because again, it really is very easy. That 2 goes into 18 how many times? 9. 9. What's 3 times 9? 3 times 9. 27 over the square roots of 3. If I was doing the exact, and you can do 27 divided by square root of 3 to get your answer. So I think they said nearest 10th, didn't they? Rounded the nearest 10th. If I rationalized it, I'd get 27 square roots of 3 over 3. 27 divided by 3 is 9. 9 square roots of 3 is the exact answer, and as a decimal, so to the nearest 10th, 15.6 meters square. Be comfortable getting those exact answers too. Number 3. You can get to the answer earlier, and that's what they want. But you should be comfortable being able to do the exact answer. What have they given us here on number 3? A 9-inch radius. And again, we're going to be using area is 1/2 apothem times perimeter. So I'm going to draw my apothem in. Right there. Do I know the measure of this angle? That's a 45. So I know I have a 45, 45, 90 triangle. So what's this apothem? 9 divided by the square root of 2, which is different than 9 times the square root of 2, which is what 9 square roots of 2 is called. 9 divided by square root of 2. So I've got my apothem, 1/2, 9 divided by the square roots of 2, times perimeter. Well, I know this other side of the triangle is also 9 divided by square roots of 2. What would I multiply by to get the perimeter? Times 8. What's 9 times 8?
72.
72 over square roots of 2. Now, it's best not to go to decimals unless you keep all those until your final answer, because we don't want to round off to the final answer. But again, this thing works beautifully, because on the bottom, square root of 2 times square root of 2 is 2, times the other 2 is 4, and what's 9 times 72?
Wait, what did you multiply to get 4?
Square root of 2 times square root of 2 is 2. And then there's another 2 on the bottom. How much? 162? 162 inches square. Number 4, Kenton's job is to cover the community pool during the fall and winter. Since the pool is in the shape of an octagon, he needs to find the area in order to have a custom cover made. If the pool is the dimension shown at the right, what is the area of that pool? Oh, they gave us everything. Did they? Did they just do lines to the... Yeah, they did, didn't they? They made this too easy. Area is 1/2, tell me the letters, or the words. Apothem times perimeter. So area is 1/2. Do I know the apothem?
6.
6. How about the perimeter? 5 times 8, 40. What's half of 6? 3. What's 3 times 40? Was it in feet? Feet squared. Number 5, we need a little diagram. If you want to just put your paper, trace it over the one in the book, that's okay. But we want to get some sketches that look like our shapes. So see if I can get a sketch that looks like my shape. May not be to scale, but we don't care about the scale. We care about what it says. 7, 20, 16, 11. And they say round to the nearest tenth if we need to. How do you want to divide this one up?
Make a little square, a little rectangle.
You want to go up and down or sideways? Up and down. Chop right there. Okay? So area 1, area 2. Area 1, how do I get it? 7 times how much? 7 times 9. I can figure out that this is 9 because the top is 20, and I subtract the 11 from on the bottom. I have 9 left over. And area 2 is, I'm just going to say plus 16 times 11 equals 176? 239. Anybody else? We want to know the answer.
answer I said this on the
What's the final answer?
Yeah.
All right. 239, was it in feet? Feet squared. So let's try 6. Change my mind, bring it back over here. Again, let's get a sketch. We're not drawing in the book. If you'd like to purchase the book, then you may be drawing in the book. And they'll probably sell you the book somewhere around $150. For that book? Yes. 4.5 inches. 4.5. 10 and 8. These are in inches. How should we divide this one up?
Well, it's not already divided for us. It's triangles.
Do we have to? Yeah, we have to divide it. Into triangles, is that what you want to do? Chop off those triangles? You could chop off the triangles. You could actually make a couple of trapezoids, and those things are exactly the same, didn't they say? Yeah, there's that. So look at the book, not my picture. They said these were 90 and 90 right over here. When it's all said and done, we're going to have to work with those triangles anyway. That's correct. That's the trapezoid formula. 1/2 height, base 1 times base 2. We are going to have to figure out some things from these triangles anyway, so let me draw this right out here. I know I have... Oh, what do I know I have? Is that all they've given me?
Yeah. Or, no.
10, 10, 90. They say those are congruent. Well, I do know I have. There we go.
Yeah, it's 4.
I do know that is 4, don't I?
So, Pythagorean Theorem. Get the other side.
There you go. That's what we're going to do. And this is 4.5. So I know 2 of my sides. We're going to have to use the Pythagorean Theorem out here. And I'll call this little piece that is missing x. So I know x squared plus 4 squared equals 4.5 squared. There's no shortcut on this one. If I took the square root of the 4.5 squared minus the 4 squared. Let you work with the Pythagorean theorem a little bit. See if you can tell me what x is.
2.06.
2.06? And we do want to take it farther than the 10th because our final answer is going to be rounded to the 10th. Okay, 2.06. Now we have what we need, I think. Let's just do the trapezoid and then double it. Area of a trapezoid, I'm going to write the whole formula. 1/2 height, base 1 plus base 2. And then I'd need to do what to that area? To get the whole thing? Multiply it by 2. So what happens when over here I multiply it by 2? It just becomes height. What's the height of my trapezoid?
4.
4. The height is the distance between the bases. Either of these. Height is 4. What's one base? 10. And the other base, yeah, 10 minus that 2.06, 7.94. So this formula that we just created should give us the area of that whole figure.
Multiply that, or I thought you were adding that together?
I better add that together, hadn't I, Wani? 10 plus 7.94. Now we have the correct formula we've created for the area of our figure. How much? Anybody else? Is that what we're getting? 71.8 then?
Yeah.
Inches squared. Excellent. The book even thinks we're right. Number 7. The basketball court in Jeff's school is painted as shown. They want to know, A, what area of the court is blue, and they say round to the nearest foot. Well, we're not going to draw the whole basketball court out, but we are going to draw parts that I need. Let's start with the blue that's off on the far right side. See if we can't kind of figure out. Okay. So we have this shape with a semicircle there chopped out of it, and this is all blue. So, what do we have? 19 and 12? 19 and 12. So I think that's an excellent idea to find the area of the whole rectangle. 19 times 12, and I'm not even going to write the parts down, minus the half a circle over here. Well, how do I find the area of a half a circle? 1/2 times pi times the radius. What would be my radius?
56.
What would be my radius? 6. My radius would be 6. 6 squared. Now do it all at once in your calculator. Don't take the pieces. Just go 19 times 12 minus 1/2 times pi times 6 squared. Now let's not round this off because this is just one of the blue pieces. How much? 171.45?
Yep.
171.45. Now I'm trying to get all the blue, so what do I need to do with that 171? Multiply it by 2, so now we're up to what? 342.90? Okay, so 0.9. Are we done with our blue?
No.
No. Where's there some more blue still? In there, the center little piece. Now that's a circle. So I have pi r squared. Do I know the radius? Is it 3? Let's see. Yeah, radius is 3 feet there. What's 9 pi? 28.27. So I'll need to add those areas together, and finally I'll have the area of all the blue. And we'll round this to the nearest tenth, they say. Oh, nearest foot, they say. Round to the nearest square foot. Nearest foot. 371 feet square. Correct answer. That was part A. So part B, they probably want the red, huh? What area of the court is red? Round the answer to the nearest square foot. Well, let's go there. We have 2 outside circles. And those circles in red on the 2 outside, those should be easy to us. Since I have 2 circles, I'm going to go 2 times pi times the radius squared. What's the radius? 6 squared. Plus, is the center... Oh, we'll have to think about that.
Not really. They gave us the. Isn't that 6 the diameter, like the length of that circle there?
We were looking at the outside circles for a radius of 6. Now the middle circle, what is its radius?
Isn't that 3?
No.
Maybe I should ask, how are we going to get that red?
The bracket's 84.84.
How are we going to get the red?
Like the large circle.
The large circle, subtract that small circle inside it, the blue one inside it. So, well, this is the answer for our 2 on the sides. Now we need to add to it, and then I'm going to do in parentheses. The full circle is pi times 6 squared. That's the full circle, right?
Yeah.
The big one. Minus the little red one inside. Pi times, what's its radius?
3.
3 squared.
That's what I said.
Good. My point was, Jet, we weren't talking about the middle one yet. We were on the outside edges, and now we're on the middle one. So we'll run through it. What do you get? What's the final answer to the nearest foot?
.01.
So to the nearest foot?
Oh, yeah, .02. you want to run it.
So to the nearest foot, 311 feet square. Beautiful. All right, your assignment. From page 811, 1 through 28.